Okay. Alright, so for the purpose of today, I'm going to skip the motivation so we can do the procedure. But the motivation would have just been a game where the students would be, it's like going over properties of quadrilaterals and you just answer questions and it's a little like warm-up game. So now we would transition. So now that we've refreshed our memories on the properties of different quadrilaterals, we're going to use these properties to discover a new and interesting characteristic about quadrilaterals and hopefully prove why it's true. So I pulled up the task of today so that I'll keep it up so that we can all see it the whole time to remind ourselves what we're kind of working for. So the first thing here we have draw a quadrilateral ABCD. You can either use your choice if I have graph paper and rulers up here, or if you have a device at all, you can use GeoGebra if you prefer to use GeoGebra. But I want you guys to try to draw the quadrilateral so that no two sides are parallel, or no two sides are congruent, excuse me, no two angles are congruent, and no two sides are parallel. Just said that. The next thing you'll do after you draw your quadrilateral is locate and label the midpoints of each of your sides, A, B, C, C, D, D, and A. And after that, you're going to join the midpoints so that you can draw a new quadrilateral. So for instance, just to give you an idea, let's say I'm going to draw any quadrilateral here. It just turned out it looks like a kite, but however you want to draw it, doesn't matter. So then we're going to find our midpoints. Obviously, I wouldn't just guess to me. I would really calculate them. And we're going to connect them and make some conjectures about that new shape that we have, that new quadrilateral. So after you draw that new one, I want you guys to make some noticing, see if there's anything that you notice about this new quadrilateral that's inside the original one, and make sure that you write down your observations. I have extra markers up here if you want to write on the table so you can remember, or you can do it on the back of your graph paper, on the computer, whatever you prefer. And then the last thing we're going to do is suppose our quadrilateral lies in the coordinate plane, so anywhere on the plane, right? So we're going to think about how can we label arbitrary coordinates. You know, like on GeoGebra or on graph paper, we can actually label our coordinates, maybe like 1, 2, 2, 3, you know. But we're going to think about how we can do that arbitrarily. By the way, does anyone know is there confusion on that word? Does everyone understand what that word means? Okay. And then we're going to think about how can we use these coordinates to prove the observation that you made in part B. Okay? So you guys can go ahead and either get out GeoGebra or you can come have graph paper, whatever you prefer. And I want you guys to just work on your own just for like 5 minutes and have some individual think time, see what you can come up with on your own first and really think about the problem. And just remember the first thing we're going to do is just draw any quadrilateral that you want. Doesn't matter what it looks like. Obviously, make sure it has 4 sides. Here's expo markers. How did you figure out where your midpoints were? I'm just curious.
Just did like half of what the centimeters were.
Like you
Like
did
the
half the
length,
line,
yeah.
so you measured the length. I see you drawing tick marks. What have you noticed?
That it's a rectangle, so the top and the bottom are equal, and the left and the right sides are equal.
And their length of
The
the sides?
lengths and the widths.
Is there anything you can notice about maybe the slopes of the lines? Okay, so I'm going to kind of pause you guys where you're at for a minute because it looks like you guys have all started making lists of different things that you've noticed about your new quadrilateral that's on the inside. So I want you guys to go ahead and get together in your table group of 4 and make a big master list of all the things that you've noticed, and maybe write that. Somebody can be a scribe and write that down for the whole table. So maybe discuss what you found and make a list, a master list.
Alright guys, so what'd you find? Well, the two like widths, I guess, are equal. Like, or
So
the
like opposite
sides.
lengths.
Yeah.
Yeah.
So there are 2 sets of congruent sides.
And then same thing with the angles, like the opposite angles are congruent.
Anything else?
The slopes of the opposite sides are the same.
So basically it's a parallelogram that's formed.
Good?
Yeah.
All right, so let's make a, I'm going to just write your list up here of all the things that you've noticed and see if we can discover or figure out what it seems like the shape on the inside is. So what are the things that you guys noticed about the quadrilateral inside the bigger one? Quadrilateral.
The opposite side lengths are equal,
Okay.
and also the opposite angles. are congruent.
Did everyone notice, like, did each of you notice that in all of your quadrilaterals? Okay. What else did you notice? Anything else?
The slopes of the opposite sides are the same.
Okay. Interesting. And everyone found that too? Any each of the figures? Okay. Any other properties that you found? Or do you have a guess of what maybe you think you'd classify the inside quadrilateral as?
We decided that it was a parallelogram.
Parallelogram, okay. I think I would agree with you. So we came up with a parallelogram. So did every single one of you found that? So what's pretty cool about that is, did all of us draw the same quadrilateral to start out with? No, we all had different ones. So we might guess what? What thing about, what could we guess about quadrilaterals? Maybe then. If you connect their midpoints, what might happen?
It's true for any quadrilateral
That you'll have that.
yeah.
Mm-hmm. Right. So we have some examples, but we know that doesn't give us a proof, right? Because there could be some other random four sides that come together that don't make a parallelogram when the midpoints are joined, right? So the next thing we're going to do, and we're on part C of our task now. So suppose we have a quadrilateral that lies in a coordinate plane, which you already kind of wrote that, but if we want to look at arbitrary coordinates, I know some of us, when we were trying to find the lengths of the sides, we measured them with a ruler, which is really nifty and nice to have. But if we don't have that ability and we just have to make a proof about an arbitrary quadrilateral, we can maybe see if there's some way we can use the coordinate plane to help us with that. So does anyone have an idea of how we can use coordinates, or how we can label arbitrary coordinates? What could we call them? So that's not saying, like that's not, an arbitrary coordinate wouldn't be 1, 2, because that's, how do we name coordinates that don't have numbers? Does anyone have an idea?
Variables.
Variables. So what would that look like? A,
comma, B.
okay. And what if so let's say we have our quadrilateral. So let's say this is AB. What could we call this one to make it different?
Plus something.
A plus something. Does anyone else have another idea?
CD.
Okay, CD. So what I had in mind, so this is kind of an idea of something that might be more helpful and give some, can't think of the word, it's escaping me. But it keeps things organized, right? So we have x1, x2, x3, x4, y1, y2, y3, y4. So it kind of helps us keep everything organized. So let's say that we have some arbitrary quadrilateral that is on some coordinate plane, and we don't want to name our coordinates, right? Because that's not going to give us a proof for all quadrilaterals. It's just going to be one specific one. So if we want to make one for all of them and use these coordinates, I want you guys to work together as a table group, or maybe just in partners, of how you could maybe go about doing that proof, and think about moving through it the way that you did with this quadrilateral, where you actually named your coordinates and measured side lengths and things like that, but how you might do that and work through that with these arbitrary coordinates. Is that clear to everyone? Yeah. Does that make sense?
Yes.
Okay.
Oh yeah. Thank you. Okay, so let me know.
That's fine.
Or maybe write down your steps as you go along. Keep in mind this is rough draft talk, no need for it to be perfect. But it might help you if you write down maybe your thinking process or the steps that you're taking to come to a final conclusion. So you don't forget. So how are you guys thinking that you could find the midpoint? Since we don't have actual coordinates, how do we figure that out? I see you have some things written down here.
We add the two endpoints of the line that you're looking at. You add the x coordinates together, and then divide them by 2, and then you do the same thing for the y.
Because that would be halfway between.
Yes.
Okay. I like that. Does anyone have any rough ideas in their heads of how we could go about proving that a shape is a parallelogram? How would we prove that?
You can find the slope
Mm-hmm.
of the sides.
You can also do the distance, like to show that like they have the same slope but also the same
Mhm.
length.
Like, so distance formula. That's good. That's a good point. So Tia, how are you going about figuring out the slopes? Since we don't have real numbers here.
I'm just taking like this point minus this point.
Okay,
So,
so
like-
so you labeled your midpoints with
Yeah.
your
Yeah.
original.
Sorry.
There you go.
I really like everything wrong. Okay, let's make this in here. These ones. These.
It's so quiet.
Can I have the eraser, please?
Okay, I'm gonna stop you because I think that's the end of my time. I think that's been 10 minutes. Has it been?
Yeah.